Hello, hello. This is the second stream of the day for animating water droplets falling into a cup using OpenGL ES 2.0 Android. I'm not very adamant on using OpenGL ES 2.0, but uh, somehow OpenGL ES 2.0 was the choice when I started, but I might have to migrate it to OpenGL 3.0. I don't know. I said I would be back by half an hour, but you know how things are, and I'm back after more than an hour late. I'm back after more than an hour, not more than an hour late. Like I stopped streaming at 12:45, I guess, and now it is 2:25. So yeah. So the new thing is, I do have a tendency to get spaced out, especially when things get a bit trickier, harder, and there is lot of reading to do and all that. And I'm comfortable in that spaced out world. So there is a sense of urgency that is also present in case of this stream. And this is something new that I'm trying out because usually this is not my speed. I take my sweet time to understand concepts and do things, but he will here I will try and speed things up. That is also one of the reasons I stopped streaming after 2.5 hours in the first stream because I didn't think I would be able to keep up the speed. Although it was not like very fast, but for me it was a bit fast. So yeah. Uh, okay, now I need to understand where I was, right? So the thing now we were doing is uh, we were trying to use a frame buffer object, right? This frame buffer object is required to do the computations, and this of buffer object needs to be refed into the OpenGL pipeline in order to make sure that uh, we use we get a sequence of frames, right? And we are not feeding the same first frame again and again. So that is what we were trying to do. But apparently there is something called GL blit buffer or something which helps you to copy frame buffer in OpenGL 3.0 and above. But in OpenGL 2.0, there is no such thing as a blit buffer. But there is some sort of thing I understood. They said, according to a Stack Overflow answer, it was said that you need to first copy the you need to first bind the texture to the frame buffer, then you need to bind the OpenGLES frame buffer, and then you just need to use the same texture as parameters to the fragment shaders, something along this line. But I was not very clear about this idea, and I don't know how to take this incrementally towards that direction as well. That is why I was like, okay, we can stop this now or some for the last stream. But I'm back now, and we'll be trying to get this done today. So there is a sense of urgency because there is a long way to go. Because our goal was to make the droplet fall down. That was our main goal. But now we see that we are not even able to. So in order for that to happen, uh, we had to do certain stuff, and now we see that that is also not happening. As in, we had to copy to buffer object, and now we see that that is also not happening. Earlier I had tried one approach in which I was doing all the calculations in an array and not passing it to shader, and then just passing on the array. But I don't think that is that a way to go about things? I'm not sure there. I mean, that is a choice, obviously, but uh, That choice I discarded at that time, because if we already have a fragment shader and all these things, why are we doing the calculations in an array by ourselves and then passing the array? We could as well use the shaders, right? Uh, Using that array had one more advantage actually. Using that array, the sequencing was not an issue because everything happened in a sequential manner. So we had no issue um, uh, with respect to sequencing. But now we are facing that issue as well, as in because there is no sequence as such. Should I revert to that option? So the question is basically this. I'm not sure whether I should be asking this question now since I am a bit into the frame buffer thing, but I'll anyway write it down because it's a thought that came into my mind. I will write it down anyway. What, why we can't do computations in on raw in an array? Okay, one thing that was uh, at that time the cup and all were made using the array itself. So now we can't use that. That is one thing. Because I've actually created a image with cup and water droplets and all that. That is one of the reasons. But secondly, one thing that actually got me stuck was the fact that um, one thing that actually got me stuck was the fact that there I wouldn't be able to decide on the number of computations, right? That was there. I was trying to magnify the what do you call uh, magnify the array and then try and do some sort of computation on there. But uh, that by default it is not a supported structure, right? As in, if the system itself is giving you some sort of maybe we can even are there benefits? We'll just does shader code execute faster, right? That is a good question. Does shader code execute faster? Uh, so yeah, we need to identify what tasks are parallelizable and what tasks are not parallelizable apparently. And the parallelizable tasks are apparently faster at the shader level. Uh, and not parallelizable tasks anyway, we cannot write it shader. That is the answer, I guess. And we need to identify and make way of doing this, right? As in, uh, yeah, we need to identify that. Are all the tasks parallelizable, or are some tasks parallelizable, some tasks not parallelizable? Now that we need to identify ourselves, and then we need to do it. Yeah, this makes it kind of, as in, I was also under the impression of, like, there was a rigidity in that thought, and I was also under the impression it should be either purely done on a CPU or purely done on GPU. But yeah, this is the correct answer, I guess. You have to break down the problem in such a way that there might be certain parts of the problem that is unavoidably can only be done on CPU, which you cannot do it in GPU anyway. Or you have to prepare your data in such a way that it can be done on GPU. That is also an approach, I guess. But this you can only find out by actually working through it. But anyways, since textures are involved, which need to be, and there is movement involved as well, I think we have to go with the GPU approach first and see what is the limitation, or is there some sort of preparation that needs to be done on the data, and then we can. But definitely, it's a good choice to do a shader, do this exercise. So I don't think this is going in the wrong direction, at least as of now. Yeah, so I'm just writing this. So yeah, this kind of addresses. We are also trying to find out if there is a way of parallelizing some computations. So um, that is also there. Uh, so Yeah. Yeah, so this makes sense, I guess. I think we can move forward with our goal, which is of, these second thoughts do come to me after, because which is sometimes useful, but sometimes it is stopping the progress. But here, I guess it helped me to think a bit on that direction, which was helpful in general. So, yeah, that is fine. Let me see if there is at least a person watching this. So, can always hope. Which is, uh, yeah, I spaced out a bit, but yeah, I was checking something and yeah. So, yeah, sense of urgency. So, that is an important thing in the stream. That is a theme that has been incorporated into the stream. So, um, what were, I was doing the frame buffer drawing, right? As in, so yeah, so frame buffer problem needs to be addressed first. Then we can see what can happen after that. Uh, Now the coming to the point of how will we do the copy, right? We can just check once the code what is happening in case of that Stack Overflow answer first. Then maybe we can try some approach. Let's just check that code first. Maybe if nothing works out today, well, in the worst case, I'll try some other offline resource offline as well, and then come back to you with it. But that shouldn't be the case. But anyway, you never know. Sometimes you try your best, and maybe yeah. Let's see what will happen. But before that, we'll give it your best anyway for next 3 hours, I guess. So, but 3 hours is the 4 hours is the most optimistic, but 3 hours, 2 to 3 hours will also work. Yeah. I'm spacing out here, but it is fine. Spacing out alert. So yeah, what was the answer there? So you do a GL draw elements. What is the difference between GL draw elements and GL array, right? Draw array. That is a question. What was the rendering thing that I used? GL draw arrays. So what is the difference between? So by the way, yeah, I think I didn't change the screen. So I was looking into this and I saw that initially the viewport was set into some, and then you use the use program, and then after which you did a GL draw elements, right? Okay, now I want to understand what is the difference between draw elements and GL draw elements and GL draw array. That is the first question that comes to my mind. Okay, that is one question. Now we'll again explore the code and see what else we can find. Okay. You do some matrix operation after that. Okay, this, and then you do GL use program and bind buffer this. Okay, next we can see what all is associated with the program. The create program is there, right? That is one question that keeps on coming to my mind. What all is associated with a program? Program is that MUse program, that OpenGL ES API that use. What is happening in those cases, right? This is the program that I was saying, not anything else. Okay. Now, are there any other questions? Uh, we did a GL use program, and then we did some sort of uniform matrix bind buffer and all that. Then we did a draw elements. Then we did some matrix manipulations. Then switched to the other program, the one that is from the frame buffer to the yeah. But matrix manipulation, you are not copying any values, right? Yeah, this is some scaling and yeah, all that. And in here, M draw list buffer. Okay, this is M draw list buffer. Yeah, I don't see any kind of. Yeah, there is nothing for this draw list buffer. And I don't see anything other than that as well here. I mean, some sort of magic should happen somewhere. What is the shader code here, by the way? Nothing seems out of ordinary in the shader code as well. Uh, that is also not helping. So we'll first see the first question. Draw element array, right? What is the difference? Yep, someone has already asked it. While refreshing my mind on OpenGL ES, I came across GL draw arrays and GL draw elements. I understand how they are using and sort of understand why they are different. What I do not seem to understand is that I fail to see how GL draw elements can save draw calls. Imagine a simple scenario in which I tried to draw a square using two triangles. Okay, this is exactly what I'm doing. I would need to have, because the 2D screen is actually two triangles, I would need to have a set of six vertices using GL draw arrays while using GL draw elements. I would only need four in addition to an array index has six elements. Given the above, okay. Okay, it is just different in the way you are approaching the problem. As in, it is anyway triggering the on draw, right? So that is one thing that I understand. The simple case of drawing quads. Okay, so at least we can abstract out there is not much of a difference. It is just drawing out things for now. If you check the parameters at least, right? In case of draw elements, uh, GL draw elements, you have triangles, vertex index size, and the draw list buffer. And in case of draw arrays, vertex count, right? So yeah, this is fine, I guess. GL draw arrays should do. Anyway, we are not doing any, so the model itself is not different. Only the manipulation is being going to be done at the texture level, not at the vertex level. So this shouldn't be an issue, I guess. Now, coming to this shouldn't be of concern as of now, at least, right? Because it's not a complex model as well. It's just two triangles for a square. Now, coming to use program, I think we initialize it at use program, right? M program, yeah, yeah. Here we initialize it. M create program, right? M program is equal to GLS. Then we attach the shaders. Then, acha. GL link program seems to be of importance here. Okay. You load texture and then you bind frame buffer. GL link program. Okay, it's an executable. It's an executable, so yeah. This shouldn't be an issue as of now. The draw elements and the draw array thing. But now the question is, for use program, we just it creates an executable. We just it is some sort of a container in which you attach the shaders, right? And do you and attach the variables. Other than that, where are you using this M program? One, use program, okay. Then yeah, in the handle and all we are passing to it, right? The side, okay. But once you do the same handle could be passed to pass to uh, the same handle could be passed to the buffer as well, frame buffer for textures at least. Uh, Not the same handle as in the same, yeah, texture data handle I'm saying that we created there, right? That texture data handle load texture. Once you load the texture, no, this could be used for either of the buffers. That is fine, but what happens after that, right? As in, you create a texture, you prepare a texture using the load texture. and you feed it to the program, right? Now the program does some sort of thing using the fragment shader and you get an output. Now, what if you do the same thing on a frame buffer, right? You do the exact same things on a frame buffer. Where will be the output present first, right? Will it be present at the texture location itself? Then I don't even need a frame buffer, right? If I keep on. So the question is, does the texture change after fragment shader implementation? After going through, right? Does texture change after fragment shader? So are you saying if you I manipulate that texture, that will be visible there? The variable that I'm getting, right? If I change that, will that be reflected in subsequent calls? If I do some sort of processing? You're getting my point, right? As in, you are passing the texture to this is a deja vu, not deja vu, what is that? Eureka moment. You are passing a texture to the shader code. Now, if we change the texture, we are showing some fragment color for each pixel, but at the same time, if we change the texture as well, will that result in a different? Will that result in a difference, right? Otherwise, we are not changing the texture. We are changing the yeah. If we have to change the texture, how would you go about it? That is the question now, I guess. You're getting my point, right? As in, I'll be more clear. When you pass the texture as a variable into the shader, now you show the pixel color based on this texture. But the texture itself is not getting manipulated, right? So now, what if during the shader code, we manipulate the texture as well? As in, you change the texture as well. But the thing to note here is that the size of the texture, as in the pixels of the texture, might be different from the pixels of the resolution of the texture and the resolution of the screens might be different. That is the only point here. But I think that might be kind of a eureka moment. I think so. I mean, it might not have been obvious to many people, but it was not very obvious. I mean, it seems obvious now. Everything, when you understand, seems obvious. So there is nothing new there. But yeah, I think that could be the case here, I guess. But let us explore on that part. I think that might be something that is of interest. Yeah, I think I'll take a break here. I'll be right back. I'll start some music. Hopefully the music goes a couple of songs. I mean, last time only one song played in the background. This is all copyright-free music, by the way, provided by YouTube. And listen to that there. Where were we?